Hey guys, Mr. Lloyd here. I'm going to work with you to show you the solutions for Friday, page 1 of 3. This is going to be a video of 1 of 3. Okay, so paper looks like this. We're going to solve problem 1 together here. So it's asking us, giving us two different expressions, 3 parentheses a plus 4 and 3a plus 3 times 4. And I'm asking you to fill out the table here to show why these are equivalent. So we'll do this quickly here. We'll just, here in the first column, our a values are given to us, so a equals 1, so I substitute 1 in. 1 plus 4 is 5, then 5 times 3 is 15. I do the same process with the other a values. 4 plus 4 here is 8. 8 times 3 then is 24. 8 here, 8 plus 4 is 12. 12 times 3 is 36. 10 here for a, so 10 plus 4 is 14 times 3 is 42. And 12 here for a, so 12 plus 4 is 16. 16 times 3 is 48. Remember, I'm going through these pretty quickly because I have to keep these videos short. If you need more time, pause the video, check the multiplication if you need to. Now, the goal here is to do the same process, substitute the values for a, and our hope is that our values here, here, and here, and for every value of a, that our two columns look exactly the same. I'm just going to use a red pen here to see if that comes true. So a equals 1. 3 times 1 is 3, plus 3 times 4 is 12. So we know that 3 plus 12 is 15. Here we're going to substitute 4 in for a. 4 times 3 is 12. 12 plus 12 is 24. A here equals 8, so 8 times 3 is 24. 24 plus 12 is 36. Take a look. We should be having the same values in for each value of a. Each expression value should be the same. So far, so good. Let's keep going. A equals 10, so 10 times 3 is 30, plus 12 is 42. Very good. And then last one, a equals 12. So 12 times 3 is 36. 36 plus 12 equals 48. So take a look. Each column in your table, the values are the same for the expression. If they have equal value, we call them equivalent expression. I'm going to pause so I can set up. Well, actually, before I pause, I'm going to show you number 2 is asking you to create a story to explain why 3a plus 4, so a similar expression, and how we could represent this as a real-life problem. So remember, guys, this is something we've done a handful of times in class. It may have been a few weeks since we've practiced this explicitly, but we have done this a number of times. So I came up with an example. I'm not going to create another one, but for example, a is the number of our avocados. So at Super 1, each avocado costs $3. That's where the 3 comes from on this problem. And then they charge $4 for delivery for groceries, so that's the plus 4. So I could buy 10 avocados, and I could find out that I just multiply 10 times 3 plus 4 and find out how much it would cost to buy 10 avocados from Super 1. I could use that expression to find out how much 100 avocados cost. I could find out how much 50 avocados cost, and so on and so forth. That's why we use these algebraic expressions, very powerful math tools. Okay, I'm going to pause real quick. All right, so final question here for part 1 of 3. It's a simple distributive property problem. Remember that the thing you want to remember is that parentheses imply an operation. In math, they always imply multiplication. So this expression is 3 times 1 plus 3 times 20m. M is our variable and it's our unknown. So here, for these problems, remember we're just distributing 3 across to 1. I'm going to write it with the x just like I do in class. Okay, and I'm going to say, what is 3 times 1? Well, it's 3. And then what is 3 times 20? Well, it's 60. And then m stays the same. So that's all we needed to do for that last one. Okay, that's it for this first video. The next two will be posting very shortly. See you then.